Okay, so hello, my name's Phoebe, this is Bea, Natalie, Kieran and George, and our presentation today is about impact, which is about asteroid collisions with the Earth. When considering that these asteroid collisions with Earth are very unpredictable, but yet incredibly common, we all thought that it was an extremely relevant and exciting topic. So during this presentation, we're going to discuss different factors that affect the energy during an asteroid collision, and also the human effects that different asteroid collisions would have. But first, we need to discuss what an asteroid is and their origins within our own solar system.
Okay, so over to me now. I hope you're not all too tired to listen to this because this is the last one. Okay, so first off, I'm going to be talking about asteroids. Asteroids are made of a mixture of metals, carbon, and silicon compounds, loaded up in various ways depending on where they're formed from. The asteroids are made from pieces of other planets that are scattered as leftovers from their formation. When Jupiter was formed, its colossal mass attracted many small objects from surrounding planets, forming a ring around the Sun between Mars and Jupiter, which is the asteroid belt. These asteroids have potential energy, which becomes kinetic energy when it starts to move. There are many forms of kinetic energy, such as rotational and translational, which in this case is the latter as it moves directly from one point to another, rather than a circular motion like the rotational. The kinetic energy is dependent on the mass, m, which is the mass is effectively the size and the weight of our asteroid, and the velocity v, which is the direct speed the asteroid is travelling at.
Okay, so first of all, before we look at velocity, we need to look at the orbit of an asteroid. So you may be able to see that it is not actually circular, it is an elliptical orbit, so it's more oval shaped. The most important part that we need from this is the distance from the middle to the end lengthwise, because that is the semi-major axis. And the reason we need that is because we need it to work out how fast an asteroid actually is, using this equation, which is velocity is equal to the square root of mu, which in this case is a standard gravitational parameter, which is gravitational constant times the mass, all times by 2 over r, which is distance between orbiting bodies, minus 1 over a, which is the semi-major axis. And we kind of theoretically made up an asteroid and gave it a value for a and a value for r, and then used gravitational constant with mass. I was incorrect. Mass does not actually matter in space. But we bumped a bunch of numbers in, and we got the speed of an asteroid, which we got to be 39 kilometers a second.
That's quite fast. Humans can also travel quite fast, and the fastest Usain Bolt can travel is 45.7 kilometers per hour, which is equivalent to 0.012 kilometers per second. That's about 3,250 times faster the asteroid is traveling than the human, which is quite a lot.
This is the data we collected when we used our equations to find results. As you can see, we have simulated two different materials for the asteroid to be made of, ice and rock. Usually, an asteroid is a combination of these factors, but we gave them pure materials as this is much easier for us to work out. This is the bomb that was dropped on Hiroshima on the 6th of August 1945. It had a lot of energy, and it dissipated most of it across the surface of Japan to great effect. This is an asteroid that we created of radius of 40 meters. Were this to hit the Earth, it would have the same kinetic energy as this many Hiroshima bombs. However, that would be quite a small asteroid. An asteroid with radius of 100 meters, were it to hit the Earth, would have the same amount of energy as this many Hiroshima bombs. And finally, an asteroid, fairly large one, but reasonable, with a radius of 500 meters, if it hit the Earth, it would have the same energy as this many Hiroshima bombs. Unfortunately, Microsoft PowerPoint can't yet deal with 1 million pictures of the same bomb in one slide, so we'll get back to the video.
Okay, so now that we know the effects that energy can have on the Earth, we need to think about the implications that this could have to human life. And one of the most major factors we decided to consider was the location of a specific impact. For example, if an asteroid were to hit Earth, say on land, it might hit one of the world's major cities, such as Tokyo in Japan, Paris, Washington, and this of course would cause mass destruction of infrastructure and most importantly the major loss of human life. However, it may also hit, say, in an agricultural heartland. This, of course, would have a minor effect on human life initially, but it could cause food shortages and things like that in the long run. Furthermore, we have to think, is this the most likely situation? When considering that 71% of the Earth's surface is made up of ocean, it probably isn't. So if you look at the diagram here, you can see that if an asteroid was large enough, it would cause a large displacement of water in the ocean, and this in turn could go on to trigger a tsunami. And we all know from events such as Japan in 2011 or the Boxing Day tsunami that were caused by earthquakes, that tsunamis can have devastating effects to human life. So say if an asteroid were to hit in the middle of the Atlantic Ocean, it could have implications to numerous number of continents such as the Americas, Africa, Europe and Antarctica. Finally, we need to consider the polar regions. So say if an asteroid was to hit in the Arctic, it would cause the destruction of sea ice and a fragile ecosystem. If it were to hit in Antarctica, it would probably cause the melting of a significant amount of land ice, which in turn would cause the rising sea levels. As we know from ideas linked to climate change, this would cause significant issues for human life, such as coastal flooding to low-lying areas, such as areas as Bangladesh and the Maldives, which are famed for their low-lying areas. So overall, we've looked at these differing scenarios, which kind of destroy our initial image of the asteroid impact on the land and give us the numerous kind of situations that it could be. So overall, we've learned about the different the different factors that affect energy during a meteor strike, and also the real significance that it could have to human life. We'd like to thank our mentor Owen and also our lecturer Matt Browning, and also you guys for listening today. So thank you very much.